Hi, I'm Brian Carrier from Basic Technology, and this is Section 1 of the Autopsy one-day training class. The goal of this section is to cover the general concepts before we make a case and start analyzing data. We'll talk about the investigation workflow, ways of deploying autopsy, and the central repository. Let's first talk about the basic investigation workflow. We'll talk about each of these steps in much greater detail as this course progresses. But the goal here is to provide some general overview of the process so you can have that as a reference. So step 1, we'll make a case by giving it a name and a directory to store the results in. Step 2 is to add one or more data sources, such as disk images or folder of files. Step 3 is to configure ingest modules that will analyze the data in the data source. Step 4 is to review the results from those modules, as well as manually look for and examine things. As part of that process, you'll want to tag files and results so that you can find them and include them in your final report. And step 6 is to make that final report that you can then copy and paste into another report or share and disseminate to your colleagues. Second concept in this section is deployment types. There's 2 ways to run autopsy. One is as a single desktop user, which you can see on the left, and the second is as part of a cluster or a multi-user environment. The single user deployment running on the desktop is what you're probably used to for most of the other forensics tools out there. In this case, the cases can only be opened by a single person at a time, and this is, again, what you're normally used to as part of other forensics tools. From a technical perspective, everything you have here is running on your single computer. It works out of the box, simple installer, hit the default answers. Every time you launch autopsy, all of the needed services come up with it and shut down with it. It's all pretty simple. The multi-user deployment, from a functionality perspective, is a bit different. In this case, the cases can be opened by multiple examiners at the same time. And if you tag something, your colleague will see it in real time, and you can both see the other's results. This also allows you to use what we call auto ingest mode, where new media is being analyzed 24/7 by multiple nodes. And this allows you to get through a large collection of data from a search warrant or something else overnight, and at 2 in the morning, when one of your data sources has finished analyzing, it'll grab a new one and start pre-processing that so it's all ready for you the next morning. You may also get faster results from this deployment because the database is often faster because they're designed to be scalable databases and not just an embedded database within inside autopsy. From a technical perspective, the user experience is exactly the same. It's the same user interface, it's all the same results. It's just that a lot of the infrastructure is on some remote computer and not running on that person's computer. Let's talk about the central repository. The central repository is a database that stores data from past cases. This includes MD5 hash values, comments about a file, Wi-Fi SSIDs, USB device IDs, etc. The reason we have it is it allows you to easily access important data from past cases. Autopsy typically has case-specific databases, and this allows autopsy to have small data sets that are easy to manage and easy to scale, and allows for easy archival, that you can kind of pull that data set out from that one case and not have it commingle with other data. But there's many use cases where that data from past cases can be important, and so the central repository is that smaller data set of the important facts from your past cases. So some use cases that we'll see later in this course. There's something called the Other Occurrences Content Viewer in the lower right-hand corner that will show you if a file or other artifact was seen in past cases and what those case details were. You can also make a comment about a file and store it in the central repository so that future cases can see the comment that you made about that file. If you did a lot of reverse engineering work, for example, on a file or a program, you can record what that program did so that future people can see the same results. With the CR, you can also centralize the management of notable hash sets or known hash sets, such as the NSRL. so you can have all of your hash sets stored in a central repository instead of having all of your examiners manage their own hash sets. And we'll also see a use case where if you flag a file as notable, then future cases will automatically flag that file. And you don't have to manage hash sets like some groups do of past notable files as a separate kind of step. It gets done automatically. That when you tag a file as notable, future cases will also have that file get flagged. There's two types to deploy the central repository. One is as SQLite, and this requires no other installations. It can be done by only one user at a time. So in this model, you say I want SQLite. It's going to make a SQLite database on your desktop computer, and you can correlate with your past cases. The big caveat here is don't try and be smart and put that SQLite database on a shared location where you have multiple examiners trying to access it at the same time. SQLite won't like that, and you'll have problems. The second approach is to use Postgres, where you have the database stored on in a database Postgres server, and multiple examiners can access that at the same time. And this can be the same server that you use for multi-user cases. So if you're going to set up autopsy as a multi-user collaborative environment, you can use that same Postgres database for both the multi-user cases as well as the central repository. In terms of picking a type for the CR, if you're a single person shop, stick with SQLite. It should cover most of your use cases. But if you have multiple people in the lab and you may want to collaborate and see all the results from your colleagues, set up Postgres. It's pretty easy. We have instructions in the user documentation on how to get it set up and how to configure it.